Hello everyone. In previous class, we studied about the application of dimensional analysis. Today, we will discuss the third application of dimension analysis, that is to derive a relationship between different physical quantities. So, third application is to derive a relationship between different physical quantities. Clear? Now the question is, how will establish the relationship between different physical quantities? So using the principle of homogeneity, we can relate the different physical quantities. So using principle of homogeneity, we can establish a relationship between different physical quantities if we know the factors on which the physical quantity depends. Clear? So this is the basic statement of this application. So we will take one example which is based on this and find out how this statement used over there. We will using how we will use this statement over there. Clear? So take one example. Derive an expression for centripetal force F, which depends on mass of the particle, velocity of the particle, velocity of the particle, and the radius of the circular path on which particle doing a circular motion. Here, this means it wants to say, suppose here we have a particle which mass is m which is moving with a velocity v, and it is given that the radius of this circular path is O. Let O is the center. So it is clearly mentioned over here. We have to express this quantity for force, which depends on the dependency of this force is on mass of the particles. That means it depends on the mass. First part is mass, velocity of the particle, so v, and radius of the circular path, that is r. And this F depends on these three terms, that is m, v and r. But we don't know how much this mass will be taken, velocity, what is the power of velocity and radius, we don't know. So let this factor be A, B and C, as we have discussed in dimensional formula. So removing this proportionality sign, we have a constant K, M, A, V, B and R, C. Clear? Where K is the proportionality constant. Clear? If K is the constant, so value of this, let the value of this constant is dimensionless. So let K equals to, or let it be whatever the value of this constant, that is dimensionless. So we haven't to bothered about the K. So as we know that if we will move in LHS side, it is F. Clear? And we know that dimensional formula for F is MLT minus 2. Clear? In RHS side, for mass, we have dimensional formula M. For velocity, we have dimensional formula LT minus 1. For radius, we have dimensional formula L. Now, put all these in this equation. So this F, or you can say, put the dimensional formula of F over here, it becomes MLT minus 2 is equals to K M. So M to the power A, V, that is LT minus 1 to the power B, and last is R, in place of R put L power C. Clear? So take the value of K is equals to 1 or leave it. So this becomes M to the power A. M has a unit L. Here L into B, that becomes B. And here L with power C, so these two will be added. So B plus C. T to the power minus D. Clear? And this is MLT minus 2, or you can say M1 L1 T minus 2. Clear? So according to the principle of homogeneity, we can add, subtract and compare the same quantity. So and one more thing, according to the principle of homogeneity, dimensional formula of these two terms must be same. So if these two terms must be same, so compare the power of first mass, then L, then T. So here M to the power here is A and here is 1. So this we can say A is equals to 1. Clear? Take it as equation 1. L to the power B plus C, here L to the power 1. So can we say this B plus C is equals to 1? Clear? Let this is equation number 2. And T to the power minus B, T to the power minus 2. So minus B is equals to minus 2, or minus cancel out. B is equals to 2, take it as 3. Clear? Now put the value of B in equation 2. So put the value of B in equation 2. So C is equals to 1 minus B, or C is equals to 1 minus B. Value of B is 2, so minus 1. Or you can say C is equals to minus 1. Clear? So from here we can say A is equals to 1, B is equals to 2, and C is equals to minus 1. Clear? Now put this value in this equation. Clear? So this F becomes, F is equals to m to the power A. So m to the power 1. V to the power B, or V to the power B, value of B is 2. R to the power C, or R to the power minus 1, or we can say mb square by R. So this is the relationship, and or you can say this is the expression for centripetal force, that is mb square by R. As we have already studied in class 9, the value of centripetal force is mb square by R. Clear? Okay. So next is next we will discuss some numerical based on these applications. So first example that we have, convert 1 kilometer per hour into meter per second. Clear? Okay. So how will do it? Again, kilometer per hour or meter per second. These are the units of velocity. So here we can find out the quantity that we have to convert is velocity, and we know that the dimensional formula of velocity is Lt minus 1. Clear? So kilometer per hour. So simply we'll put one system of unit, or here another system of unit, Clear? So in here N1, it is given that value of N1 is 1. M1 kilometer per hour. So kg is, so value of M1 is 0. Clear? L1 is equals to 1 kilometer and T1 is equals to 1 hour. Clear? N2, that we have to calculate. M2 is again 0. L2 is equals to 1 meter and T2 is equals to 1 second. So we know that the formula for N2, which is equals to N1 M1 upon m2 whole to the power a, L1 upon L2 whole to the power b, and T1 upon T2 raised to the power c. This can also be written as m0, L1 and T minus 1. So from here you can see value of a equals to 0, value of b equals to 1, and value of c equals to minus 1. Clear? So value of n1, it is given that 1, m1, so here value of a is 0, so this whole quantity will become 1. Here L1 upon L2, L1 is 1 kilometer, so 1 kilometer upon L2, that is 1 meter, value of b is 1, T1, that is 1 hour upon 1 second whole to the power minus 1. So 1000 meter upon 1 meter whole to the power a, 1 hour, that is 3600 second upon 1 second whole to the power minus 1. So this becomes 1000 into 1 upon 3600, or this becomes 5 by 18. So value of n2 is 5 by 18. So put it over here. This becomes 5 by 18 meter per second. Clear? Next. Next question, convert 20 meter per second into kilometer per hour. Clear? Again, here the term is, the quantity is velocity. So we know that the dimensional formula of velocity is Lt minus 1, or you can say m0 L1 T minus 1. So again, value of A is 0, value of B is 1, and value of C is minus 1. So one system of unit, another system of unit. In first system of unit, value of n1 is 20, mass, that is m1 is equals to 0, L1 is equals to meter, that means 1 meter, and T1 is equals to 1 second. Another system of unit, so n2 that we have to find, m2 again 0, L2 is equals to 1 kilometer, and T2 is equals to 1 second. Clear? So n2 can be written as n1, m1 upon m2 whole to the power a, L1 upon L2 whole to the power b, and T1 upon T2 whole to the power c. Value of n1 is 20. Put it over here. So this is 20, and value of A is 0. So this quantity will become 1. L1 upon L2, that is 1 meter upon 1 kilometer. So 1 meter upon 1 kilometer whole to the power B, and value of B is 1. T1 upon T2, that is 1 second upon 1 hour whole to the power minus 1. So 21 meter upon 1000 meter, 1 second upon 3600 second whole to the power minus 1. So 20 into this is 1 upon 1000 into this will move forward upward. So this becomes 3600. 1 2 1 2 here 10 2 ja and 36 2 ja 72. Clear? So here value of N2 is 72. So put it over here. This becomes 72 kilometer per hour. Clear? In next class, we will discuss some more numerical based on these applications. Thank you.